Course 3, Lesson 86, we are looking at the volume of pyramids and cones. So the goal of this is basically what is the relationship between a pyramid and a prism and the relationship between a cone and a cylinder. How can we use those to our advantage? So overall, we need to start with looking at how do we find the volume of cylinders and prisms, because that will help us with our goal of cones and pyramids. So our overall formula is volume equals the area of the base times the height. This will work for any cylinder or prism. We just have to change how we find the area of the base based on what we have. So let's look at a couple of these. So if we take this prism right here, well, our base, since this is a rectangular prism, our base can be any of these sides, any of these faces. Let's take this as our base. So we need to find the area of the base. Okay, so if we want the area of the base, that is going to be 10 times 8. And then if we want to multiply it by the height, we are going to multiply by this 6. So in total, we get 480. And since we're in volume, we are in inches cubed. So we just do the area of the base times the height. Pretty simple. Let's try another. But let's use a cylinder this time. Well, the area of the base, that's going to be the area of this circle. So to get the area of a circle, we are going to need pi r squared, since that is the area of a circle. That's how we find it. So we can plug that in and say we have, and since we're leaving it as pi, we have 4 squared pi. And our height is 9. So if we put it into our formula, we have 16 pi for the area at the base times the height of 9. And so when we multiply that together, let's see, 16 times 9. 6 times 9 is 54. 9 times 1 plus 5 is 4. 144. So we have 144 pi centimeters cubed. Okay? Well, the reason that we go over this so that we can talk about cones and prisms is because they are related. If you can believe it, each cone that we have, if we were to fill it up with water or rice or whatever you want, we could take 3 of those to fill 1 cylinder. Okay? Or to say it differently, if we took 1 cylinder, we could fill up 3 complete cones. So our formula for a cone is 1/3 of the area of the base times the height. So we take a normal cylinder and we can cut it into 3 cones. So whenever we have a cone, we can think, well, I'll just find the volume of a cylinder and divide it by 3. So let's do that with this one. So the area of a base, if we are given that the diameter is 12 and the height is 10. Well, this is a circle as our base, so we do pi r squared. But in this case, we're given the diameter, so we need to think about, well, the radius of the circle, if the diameter is 12, then the radius is 6. So we would say we have pi times 6 squared. So we get 36 pi. And then since the height is 10, we just need to take 1/3 of 36 pi times 10. Well, I'm just going to go left to right. 1/3 of 36 is 12 pi, and then we're going to multiply by 10. I can mix this up because it's multiplication, so that I have 12 times 10, which is 120 pi. And we are in inches cubed. If you have a problem where it says don't leave pi as pi and actually multiply it out, all we will do is take 120 and multiply it by 3.14. And we will get our answer in inches cubed. Okay? So we just take 1/3 of our original cylinder. Let's try one more. So diameter is 6, height is 5, so we can find the area of the base. So pi r squared, which is pi, times 3 squared, which is 9 pi. And our height is 5. So we say, I want the volume is 1/3 of 9 pi times times 5. And we will end up getting a volume of 15 pi inches cubed. That's as simple as it is. Just remember the area of the base in this case is a circle, so pi r squared, multiply by the height and divide by 3. So the question is, how does a pyramid fit in all of this? Well, it fits the same way. We can say that there are 3 pyramids within one prism. Or you can say, if I have a prism, I could fill up 3 if I have a prism, I can fill up 3 pyramids with that amount of space. So it's very similar. I'm going to take 1/3 of our prism. So let's try this one. The length of the base is 90 centimeters. So 90 by 90, and the height is 50. So the area of the base is 90 times 90. Since this is a square, that's kind of nice. We just get to multiply like that. And the height is 50. So I just plug it into my formula. Volume equals 1/3, and then 90 times 90 is 8100. We multiply by 50, and when you multiply all that out, I believe you get 135,000 centimeters cubed. Just plug it in the formula and work from there. That's it. Another example. This one says that the area of the triangular pyramid base is 36√3 units, and the height is 10 units. Well, you may look at this and say, well, I don't know what to do with this because I've never seen that √3 before. Well, actually, what's nice about this is it's already going and doing a step for you. It's already found the area of the base, okay? Which means that we just say it's 36√3. And the height is 10. So when we plug in the formula and say volume equals 1/3 of 36√3 times 10, I can just multiply out. 1/3 of 36 is 12√3, and then we multiply by 10. Well, I can't multiply the 3 and the 10 because the 3 is under a radical symbol, but I can multiply the 12 and the 10. So I get 120√3, and I believe we're in units cubed. So if you are given the area of the base, that's great. It actually helps you out quite a bit. Okay, so we're back to this one that we had earlier that's very similar to this. We have side lengths of 90 by 90, a height of 50, but this one says if a new pyramid are 1/10 of the original dimensions, find the volume of the smaller and determine the percent of change of the volumes. Okay, and we'll show that as a fraction. So instead of having 90 by 90, I want 1/10 of 90, which means that my side lengths are just 9. And I want 1/10 of 50, which means my height is just 5. So if we do our volume of the pyramid, I'm going to do 1/3 of 9 times 9, because that's the area of my base, times my height, which ends up giving me 135 centimeters cubed. The question is, how much smaller is this? Well, as we've learned in the past, this 1/10 is our scale factor, and that's just for the side lengths. So 1/10 is for the sides. What we have also learned is that if we take that scale factor and square it to get 1/100, that would be the scale factor for the area. And finally, if we take our original scale factor 1/10 and cube it to get 1/1000, that will give me the scale factor for the volume. So we can see that this volume is 1/3 1,000th of the original volume, which would make sense because if we go back to our original problem over here and see we have 135,000, well, 1/1,000th of 135,000 gives us 135, which is exactly what we got when we scaled it down by a tenth on each of the dimensions. Okay? Once again, when they give you things like this, all right, it's giving you the base already. So we do 1/3 times 18 root 3 times 12. We get the volume. Okay? Using a 12-inch cube of clay, he makes a 12-inch high pyramid with a 12-inch square base. What's the volume? Does he have enough clay? And when you do this one, you'll see that you'll need to do 1/3 of 12 times 12. That'll give you the base. And then times 12 will multiply by the height. And you will see that he does have enough. Well, I hope that this was helpful for studying and for your homework.